Hello children, in this video we'll talk about the parallel combination of resistances. Here in figure 1 you are given three resistors R1, R2 and R3 which are connected in a parallel combination. Here V is the total potential difference applied by the battery. So V is the total potential difference across the combination. We see here that R1 is connected via A to the positive terminal of the battery and via B to the negative terminal of the battery. So R1 is directly connected to the battery, so it is enjoying the full potential given by the battery. Similar is the case with R2 and R3. Both of them are connected via A and via B to the positive and negative terminals of the battery respectively. So both of them are also enjoying the full potential given by the battery. So we see that in a parallel combination, the total potential difference across each resistance is same and it is equal to the total potential applied by the battery. That is, potential V is same across each resistor in a parallel combination. Now let us talk about the current. Look here in the figure. I is the total current supplied by the battery. At point A, this current I has three paths to flow, so it divides itself in these three paths. The current through R1 is I1, through R2 is I2, through R3 is I3. When these three currents flow through these three resistances, then after passing through these resistances, they will again recombine at point B to again give the total current I, which will further flow through the circuit. So we see that in a parallel combination, the total current is equal to the sum of currents in the individual branches. That is, I is equal to I1 plus I2 plus I3. Now let us find out the equivalent resistance of this parallel combination. To do so, we replace these three resistors by one single resistance Rp, such that on applying the same potential V across this Rp, you get the same current I. Here Rp is called the equivalent resistance of the circuit. To find the value of Rp, we apply Ohm's law to figure 2 and then to figure 1. On applying Ohm's law to figure 2, what we get? We get I is equal to V upon Rp, that is this equation. And on applying Ohm's law to individual resistors R1, R2 and R3, what we will get? On applying Ohm's law through R1, we will get I1 is equal to V upon R1. On applying Ohm's law to R2, you will get I2 is equal to V upon R2. And then I3 is equal to V upon R3. That is, you will get these three equations. Now substituting the values of I1, I2 and I3 in the above equation, that is this equation, we will get V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. On cancelling V from both sides, we get 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we see here that the reciprocal of Rp is equal to the sum of reciprocals of R1, R2 and R3. So this gives us the law of combination of resistances in parallel. It says that when a number of resistances are connected in parallel, then the reciprocal of equivalent resistance is equal to the sum of reciprocals of individual resistances. That is, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Now some important points here. The first point is that in a parallel combination, the potential difference across each resistor remains the same and it is equal to the total potential difference applied across the combination. The second point is that the total current divides itself such that the total current is equal to the sum of currents through individual resistors. Third point is that the equivalent resistance is lesser than the least resistance in the combination. For example, let us take two resistances R1 1 ohm and R2 3 ohm. When we find the equivalent resistance of this parallel combination of R1 and R2 using the parallel combination formula, we get the answer 0.75 ohm. Here 0.75 ohm is lesser than the least of the two resistances, that is 1 ohm. So we can say that the equivalent resistance in a parallel combination is lesser than the least resistance in the combination. The fourth point is, if n resistors, each of resistance R, are connected in parallel, then equivalent resistance Rp is given as 1 upon Rp is equal to 1 upon R plus 1 upon R plus 1 upon R n times. You will be adding these n times. You will get n upon R. To find Rp, we'll again take the reciprocal of this, that is Rp will be equal to R by n. Now let us solve one question relating to parallel combination. Here you are given three resistors R1, R2 and R3 connected in parallel. Their values are 5, 10 and 30 ohms respectively. They are connected across a battery of 12 volt. You need to find the total circuit resistance, that is the equivalent resistance, the total current in the circuit, that is this current, and the current through each resistor. Let us solve part A, that is finding the total resistance. Using the formula for parallel combination and inserting the values of R1, R2 and R3 and then solving by taking the LCM, you get 1 upon Rp is equal to 1 by 3. Again taking a reciprocal to get Rp, you see Rp is equal to 3 ohm. So the total circuit resistance or the equivalent resistance is 3 ohm here. Now, to find the total current through the circuit, you apply Ohm's law. That is, total current is equal to total voltage by total resistance. Total voltage is the one supplied by the battery, that is 12 volt, and total resistance is 3 ohm. Total resistance is the one that you found above, that is 3 ohm. So dividing 12 by 3, you get 4 ampere. So the total current in the circuit is 4 ampere. That is, this current is 4 ampere. Now in third part, we need to find the values of these I1, I2 and I3. To do so, we apply Ohm's law to each individual resistance, that is R1, R2 and R3. On applying Ohm's law across R1, you get I1 is equal to V upon R1. V is 12, that is common for all the three. R1 is 5 ohm. The value of R1 is 5 ohm. Dividing, you will get 2.4 ampere. Now again applying Ohm's law to resistance R2, you get I2 is equal to V upon R2. Inserting the values of V and R2, you get 1.2 ampere. Similarly, finding the value of I3 through R3, that is V upon R3, you will get zero point 0.4 ampere. Please note here that the values of I1, I2 and I3 are 2.4 ampere, 1.2 ampere and 0.4 ampere respectively. On adding these three, adding I1, I2 and I3, you get 4 ampere, which is the total current I. So total current is equal to the sum of individual currents. This is all about parallel combination. Students, sometimes in a circuit we have a combination of series and parallel circuits. One circuit will have series combination of resistors as well as parallel combination of resistors. So how to solve such circuits? We will have one more video relating to this. Please watch that video following this.